Good day, doctor. So our group will present theory of structure case study Skab 3243. So the topic is total collapse of a six storage reinforced concrete buildings. So I'm the group leader. I'm Bing Feng, and here is my group members Yong Sheng, Theam and Lois from Xiuan. Okay. Next, this is the table of content. It shows that what we will present for the whole case study project. Okay. Next, go through the introduction. So for the collapse building is called New World Hotel, also known as the Lun Yit buildings, collapsed on 15 March 1986, and it was the Singapore Dead List civil disaster. The collapse left the 50 people trapped, of which 17 were rescued and the 3 dead. So it was a low-cost building which was built by a businessman named Huang Kangling. As early as 1974, the safety of the building was questioned. However, the owner of the building ignored and covered the warning sign. So before the building collapsed, it was locked by the new installation, included a water tank, 2 water heaters, a cooling tower, condensing units of the air conditioning system, also another 15 tons from the tilings of the building. So the collapse of the unit buildings is a type of progressive collapse. So in this failure, the progressive collapse was due to the poor design of the structural system. So all the columns were stressed to their limit and on verge of failure. Okay, and then I will pass to the next presenter.
Hi, I'm Go and I will continue discuss on the objective for our case study. So there are 4 main objectives for our case study. For the first one, we want to investigate the main cause of the hotel new world collapse. So for the second one, we want to identify the possible cause for the structural failure. Third one, we want to suggest the recommendation for the existing structure or infrastructure. And the last one, we want to highlight the lesson learned from our case study. Next, I will continue discuss on material assessment. As we know, our hotel new world is mainly made out of reinforced concrete. So for our material assessment, we will mainly discuss on the test on concrete. So there are 2 types of concrete tests. The first one is a disruptive test. The second one is a non-disruptive test. So for the disruptive test, we can determine the weakness of concrete design, which cannot be seen under the normal conditions. It also can use to determine the compressive strength, crack, and other imperfection of a concrete. So for the disruptive test, we decide to use a compressive test on concrete core. On the other hand, for the non-destructive test, it is concerned about the evaluation of flaws or defects, such as crack, which might cause the loss of strength of concrete structures. So, for non-destructive tests, we decide to use 2 tests. The first one is an ultrasonic pulse velocity test. The second one is a reborn hammer test. So, I will continue further expand these 3 tests. So, for the first test, the compressive test on concrete core. So, this is the most reliable test and the faster test to determine the compressive strength. It is very simple. Okay, we just need to take a few core samples from the in-situ concrete and take it to the laboratory to carry out the compressive strength test. So, before we carry out the compressive strength test, we can actually do some visual examination. So, from the visual examination, we can see that the aggregate arrangement or size or characteristic, and we also can see the crack of the concrete or other imperfection of the concrete. So, for the second test is the ultrasonic pulse velocity test. This is actually used to determine the homogeneity and the integrity of the concrete. So the concrete with any discontinuity or any crack will cause the wave to take longer time to pass through the concrete. So for the third test is a reborn hammer test. This is actually the concrete hardness tester. It can use to determine the concrete hardness. So it means that the lower value of reborn hammer value, it means that the concrete have a lower strength. So that's all for me for the material assessment. Thank you.
Good day, lecturers. My name is Lois, Chong, and I will now proceed to discuss the structural assessment of our case study. It is a procedure used to check the adequacy, the structural integrity, and soundness of structures and also their components. So this is an assessment made to evaluate a structure's current and future use, whether it is conformance to the current building codes. So there are some of the objectives of this assessment of an existing structure which can be used in our case. First one is to assess the possibility of a change in use of premises. Second, to assess the reliability of an existing structure in case of a change in the static model of structures, for example, the floor additions. Third, we have to assess the reliability of an existing structure with respect to its degradation, for example, the defects and faults of a structure. And the last one is to assess the reliability of a structure with respect to its damage by extraordinary loading. Now let us look into the examples of structural assessment. Firstly, we can have pull-out tests to check the concrete strength. It is to evaluate the strength of concrete in existing structures. Next, we can have resistivity meter test to check the corrosion of steel reinforcement. Resistivity of concrete is a good indication of the probability of corrosion. So when conducting this test, the lower the electric resistance, the more easily corrosion current flows through the concrete and the greater is the probability of the corrosion. Lastly, we can check the integrity and structure of concrete by using load tests. The performance of concrete structures should be maintained at standard so that the building is safe enough for use. So by using these load tests, we can establish the existing condition of structure, identify issues affecting the structural performance, and develop any immediate actions that required. Now, let us look into the structural design and analysis of our case study. And in any method of structural design and analysis, there are some of the common steps that need to be followed. First, you have to assess the dead loads and other external loads that's applied to the structures. Second, you have to determine the design loads from different combinations of loads. Third, you have to estimate the structural responses, for example, bending moment, shear force, axial thrust, and etc. due to the design loads. Lastly, we have to determine the cross-sectional areas of concrete sections, and by using these cross-sectional areas, we can know the amounts of reinforcement needed. So in our case study, we choose the limit state analysis as it is one of the common analysis methods in structure. So limit state analysis uses more than one safety factor to provide adequate safety at ultimate load. It is also ensure that they will not reach limit state and will not become unfit for the use for which they are intended. There are two main limit states. First, limit state of collapse. It deals with strength and stability of structures subjected to the maximum design load. It ensures that neither any part nor the whole structure should collapse or become unstable under any combination of expected overloads. Second, limit state of serviceability. It deals with deflection and cracking of structures under service loads, durability under working environment. So the formula, design rules, and specific limitations for all of these mechanisms can be determined easily by following Eurocode 2, which is the latest, the safer, and more advanced design guidelines if compared to the British standard. So we have to check the characteristic strength of the material, the partial safety factor, gamma M for material, for example, 1.5 and 1.15 for concrete and steel partial safety factor respectively. And we have to check the design strength of material FD, which is the formula of the characteristic strength of material divided by the partial safety factor gamma.
Hi doctor, my name is Xiao and now I'm going to present the maintenance for our case study. So the main purpose of maintenance and having regular inspection is to avoid or mitigate the deterioration of the structural elements of the building. In our opinion, it is crucial to have regular maintenance and periodical inspection. In this connection, the following aspects need to be considered. First, suitable frequency of inspection. Since the purpose of the inspection is to detect and identify the structural defects, an inspection every 5 years would be sensible and should suffice. And second, extent of inspection. Firstly, if the structural plan and calculation are available, then they should be checked. Such checking should be along the line of the structural check. Secondly, a visual inspection, including non-destructive testing for signs of structural deterioration, should be carried out. There might be some difficulties in checking all the structural elements of the buildings, as some of them would have been covered up. However, an inspection to a certain extent can still be carried out and would not be entirely fruitless. Third, report from the engineer who carried out the inspection. A clearly written report should be provided by the professional engineer which has been conducted the inspection once the inspection of the buildings is completed.
Okay, next, we go through the buildings bylaws. According to the Uniform Building Bylaw 1984, the dead and the imposed load and wind loads shall be calculated. Dead loads shall be calculated from the unit weight given in BS 648 or from the actual non-weight of material used. The provision relating to dead and imposed load shall apply to first is new buildings and new structure. Next is structural alterations and additions to existing buildings and existing structure. And next is existing constructions on chance of use. So in this case, the structural engineer had omitted the building dead loads from the calculation. So after this accident, the Building Control Act 1989 was endorsed together with the Building Control Regulations 1989, where the serve of purpose of providing the additional checking or inspection of work that has to be conducted by the engineer in charge. Next, we go to the safety and health. Those is the simplifications of the Department of Occupational Safety and Health, which is the department under the Ministry of Human Resource. So this department not only need to ensure the safety, health, and welfare of people at work, but also need to protect the public from safety, health hazard. which arise from the construction sector or other sector. So in the guidelines of DOSH, it stated that the general duties of architects, engineers, and designer at the planning stage of any proposed building or civil engineering works, specific consideration should be given by those responsible for the design and construction to the safety of the workers and the public. The structural engineer also have to calculate the building life load and the building depth load, and it was completed omit from the calculation. It means that the building itself have been stressed to the allowable limit from the first day, and the collapse cannot be avoided. So lastly, we can conclude that the duties of the engineer were annoyed in this case. So the engineer did not play his roles in proper designing during the planning stage as that in DOSH guidelines. So that's all for me. Thank you.
Next, the conclusion of the case study is, by conducting this case study, we have learned that duty ethics and right ethics are the fundamental moral principles that must be held by a civil engineer. It is our job to make sure that the buildings are designed properly before it is being constructed. Should there be any deterioration of structure, they should acknowledge the relevant authorities as soon as possible to avoid the loss of innocent lives or unwanted casualties. Apart from that, we have learned that never underestimate an unusual thing that is observed randomly, as it leads us to reveal a serious problem. Before the collapse of the building, cracks were noticed at several places. These cracks should be taken seriously, and they should be reported to the authorities once unusual failures are found. Last but not least, before adding additional loads to the building, experts should be consulted. To ensure the safety of the building, it is highly recommended to consult the experts before adding additional loads to avoid structural failure. That's all from us. Thank you.